Hello, CBSE Class 10 students. We have discussed in our last class regarding reflection. I have given the definition of reflection, which is the one of the important property of light. We have also discussed the reflection in a plane mirror and the laws of reflection and nature of the image formed by the plane mirror. You know that the laws of reflection is not only applicable for plane mirror, it is also applicable for reflecting surface of any shape, or it is also applicable for a curved reflecting surface. The most common curved reflecting surface we take are spherical mirrors. The question may come to your mind that what is a spherical mirror? The spherical mirrors are those mirrors which are a section of a sphere in which your reflecting surface may be curved inward or may be curved outward. So it is in two spherical mirrors. One is your concave, one is your convex. The concave mirror is a spherical mirror, is a section of a sphere which reflecting surface is curved inward. Similarly, the convex mirror is a spherical mirror which is a section of a sphere. It is a section of a sphere. That means it is a part of a sphere. Take a sphere and cut out a section of that. You take a, suppose you take a glass sphere, hollow sphere, and cut the section of this sphere, and this part, if it is glazed at outer side, that means your reflecting surface is curved inward. Similarly, it is glazed at inner side and the reflecting surface is curved outward. That is the convex mirror. So this is about your what is your spherical. Then I have already explained concave mirror, what is a concave mirror or what is a convex mirror. A spherical mirror is a section of a sphere whose reflecting surface is a curve inward is called concave mirror, and convex mirror definition is your spherical mirror is a section of a sphere whose reflecting surface is curved outward. It's called convex mirror. Before going to discuss in detail regarding the spherical mirror, we have to be acquainted with some important terms. What are those important terms? Those important terms are: one is your pole of the mirror. Pole is a pole of the mirror. The pole of the mirror is the center of its reflecting surface lies on it is commonly denoted by P. See here in the figure, see here in the figure. This is P. This point is P. This point is your this is P with the center of the reflecting surface. The center of the reflecting surface is the pole of the mirror. Then, for what is next thing is what is your center of curvature? Center of curvature. The center of curvature of the sphere, which is a reflecting surface, is part of a spherical mirror. It's denoted by letter C. The center of the sphere, of which the reflecting surface is a part. That means by taking the suppose here a concave mirror is given. Suppose is by taking the concave mirror, you can imagine a sphere, and the take the center of the sphere. If the center, imagine the center of the sphere, that center of the sphere is known as center of curvature. Center of curvature. Then another thing is so in case of concave mirror and in case of convex mirror, in both the cases you can imagine the center of curvature. Then next thing is your radius of curvature. What is the radius of curvature? So the radius of curvature, radius of curvature if you take this is the center of curvature. From center of curvature, the distance, this distance is the radius of curvature. This distance is the radius of curvature. So this is the radius of curvature. Remember what is radius of curvature? It is the radius of the sphere of which reflecting surface is the part of the sphere. Part of the sphere. So it is denoted by R. Then what is the principal axis? Principal axis, a straight line passing through the pole and the center of curvature of the spherical mirror. Pole and so So this is B and this is C. If a straight line is margined through these to the 2 points, this is called principal axis. A straight line is imagined these 2 points, pole of the mirror and the center of curvature. This is principal axis. So this is called principal. Remember all this remember all this. Then will come to focus. What is focus? Focus of a spherical mirror when some parallel rays, the rays of light coming from source of light, which is rays are parallel to the principal axis. Then after reflection in the curved surface, it will concentrate at a point. All reflected rays meet at a point at the principal axis in case of concave mirror. In case of concave mirror, and it will be see the these are the parallel rays coming from the source of light. After reflection, they will meet at a point F. This is the focus. This is the focus of the spherical mirror. In case of concave mirror, this is the focus, and this case of convex mirror, this is the focus. Actually, this focus in case of convex mirror is actually the reflected ray will not meet here. All reflected rays in case of convex mirror diverge each other, and it will extend that side of the convex mirror. They will appear meet at a point. They appear to meet at a So these are the important terms affected spherical. Some other important terms are there. Is your focal length. Focal length is the distance of between the pole and principal focus of the spherical. Distance between pole and the principal focus of the spherical mirror, and this is denoted by small f. Remember another term that is called aperture. Diameter of the circular outline, the reflecting surface of a spherical mirror, known as aperture of the spherical. See figure. See in the figure. This is the if we take the circular circular section. This is the section of the concave mirror, and this circular, the outline, this outline is a sphere. This outline of the spherical mirror, that is in case of concave mirror or convex mirror, its outline. Imagine its outline is a circle. Its outline is a circle. If we measure the diameters of this outline of the spherical mirror, and that diameter is called aperture. This diameter is called. Then we'll come to how image. We will discuss reflection through a spherical mirror. You know that the image formed in a spherical mirror depends on the image formed in a spherical mirror depends on the nature, position and size of the image formed by the spherical mirror depends upon the position of the object with respect to pole, focus and center of position of the object with respect to pole, focus and center of gravity. Where your image is situated, or to me, where the position of your object. So when going to draw the ray diagram to find out or determine the formation of image in a spherical mirror, we have to understand some rules. Obeying some rules will draw the ray diagram to show the formation of image in case of spherical mirrors. First, rule 1, a ray of light which is parallel to the principal axis, ray of light which is parallel to the principal axis, parallel to the principal axis, parallel to the principal axis of the mirror, passes through its focus after reflection from the mirror as shown in the figure. See the figure. So this, when coming parallel from the source, after reflection they will pass through the focus. This pass through the focus. This is then see second rule. What is the ray of light passing through the center of curvature of the concave mirror is concave mirror are directed in the direction of the center of curvature. See here. Yeah. So a ray coming to the center of a curvature and falling on the surface of the reflecting surface, and this will exactly follow the same path. Reflected ray. This is the incident ray, also this is the reflected. The reflected ray follow the same path as in case of the incident ray. In case of this is in case of concave mirror. This in case of convex mirror, this is reflected back and never go through center of curvature. It appears as if it is coming from center of curvature. So this is one. Then third rule is a ray passing through the principal focus of the concave mirror is always directed towards the principal focus. See, in the when the incident ray passing through focus, passing through passing through focus. Incident ray is passing through focus, and after reflection, reflected ray is go parallel to the principal axis. Go parallel to the principal axis. Similarly, here the incident ray is falling on the surface of the convex mirror as if extend it as if it appears to pass through the focus. In case of convex mirror, the reflected ray move reflected in each direction, which is parallel to the principal axis. In both the cases, same. In concave mirror, exactly passes through focus. It appears to this incident ray appears to passing through focus. You extend back side of the mirror, appears as if it is passing through focus, but actually it does not pass through focus. So after reflection, they go parallel to the principal. Another rule is there: a ray of incident light obliquely to the principal axis towards the point P on the concave mirror or convex mirror is reflected obliquely. The incident and reflected ray follow the laws of reflection at the point of incident, making equal angles with the principal axis and shown in the figure. So where you say when the light falls on a point P, suppose here light falls on at the point B, what will happen? The laws of reflection also obeyed here. Here the angle of incident is equal to the angle of reflection. Here also same the case in case of convex mirror. Angle of incident is equal to angle of reflection. So then we'll consider the image formation. Then we'll consider the image formation in a spherical mirror. First we'll consider the image formation in a concave mirror. First, if the object is at infinity, if the object is placed at infinity, its image is formed at the center focus of the concave mirror. Let's see how it is formed. How so here your object, extended object is placed at infinity, and from infinity distance parallel rays fall on the mirror, spherical mirror in case of this case concave mirror, parallel to the principal axis. As per the rule, the parallel rays passing through and falling incident on the surface of the concave mirror, it is reflected through the focus of the mirror, spherical mirror. So the reflected ray intersect point F. At F, the image is formed. It is image. This image is a point image and very small and is real. Then second position of object, that means maybe between the center of curvature and in between that. So similarly you consider ray diagram falls on the surface of the concave mirror and is reflected back. And another incident ray falling at P exactly from the same path. Your this incident ray falling at this point focus, another incident ray passing through the radius of center of curvature falls at the point and return in this path. When return on this path, intersecting each other at this point A. So the image of A is formed at the dash here. So the similarly the image of B is formed here B. So if you A dash B dash image of B in case the object is placed between center of curvature and the distance. Similarly, if the object is placed as center of curvature, the object is placed at center of curvature, consider a incident ray passing through the focus, another incident ray passing through the focus, coming parallel like this and cutting. The two reflect rays are intersecting here at A dash, that is A dash and B dash. So exactly the image size, object size is equal to image size, and object distance is equal to image distance. So in this case, the image is formed is real actually. So the nature of the image here is a point image. In this case, it is a inverted, and the image is small and real, and here some image is same size. The image distance and object distance are same, and the uh, it is inverted and real image. Next, we consider the position of the object here between a point focus and the center of curvature. In this case, we consider an incident ray falling at this point and passing through the center of curvature like this. Again, another parallel ray parallel to the principal axis falling at this point D and passing through the focus. These two rays reflect this intersecting at each other at a dash. Similarly, the reduced word dash a dash is the so the image is formed the same side of the mirror, and it is enlarged and inverted, and it's also a real image as the reflected rays are actually intersect each other. In this case, if we keep the object at focus, what will happen? We will consider a incident ray parallel to the principal axis. This reflected is passing through this. Again, consider another incident ray are passing through the focus like this. These two rays are parallel to each other. The parallel rays can never meet each other. So if they meet each other, this may be at is impossible. So the image form in this case is very large if it meets the two reflected data. So this is the last case. In case of concave mirror, if the object is placed between focus and pole, so here you see incident ray falling and going through the center of curvature. Another incident ray is falling at pole, exactly follow this path. But if we see the direction of the reflected ray, they are diverging from each other. It will extend or imaginary draw the line behind the concave mirror, cut at a point, set at a point. So the image will be seen here, a dash. Image of A is will be as A dash, similarly B at B dash. So your AB is the image of A dash, B dash is the image of AB. So this is a virtual image. This is a virtual image, unreal, not real image, because the reflected rays actually don't meet each other. Actually, don't meet each other. That is the case of image formation. So these are the explanation how image form if the position of the object is different with respect to focus, and see, this is the summary. If it is object is placed at infinity. Image position is image position at focus. Size of the point size. Center of image equal. Similarly, beyond C, image is formed between focus and center of curvature. Is small, real and inverted. Is nature of the real and inverted. Similarly, if exactly at the center of curvature, then the image is formed exactly at C, and size of the image is equal to size of the object, and the object size, image size, real and inverted. Similarly, if the object is placed between C and F, it is behind C and enlarged and real and inverted. Similarly, focus, image is formed at infinity, highly enlarged, real and inverted. Similarly, between F and C, the mirror is behind the mirror, the image is formed behind the mirror, which is enlarged, it's virtual in an erect. So this is the formation of image in case of concave mirror. What are the application of this concave mirror? The applications are it is used as torches and searchlight, vehicle headlights for powerful parallel beams of light. It is used as a saving mirror to see the image of the face. Can be used as a saving mirror to see the enlarged face of the mirror. In this case, what happens? Your face remains between focus and the hole of the mirror. As a result, you can see your enlarged form. Similarly, it is used by dentists to see the large image of the patients. Dentists use it for treatment of the. So it is also used as solar furnaces to produce heat by concentrating sunlight. So this is all about the concave reflection, concave mirror, and its formation and its application. Similarly, in case of convex, we discuss the image formation in convex mirror. The image formed in a convex mirror is always virtual, direct, and whatever the position of the object may be. When the object is placed at infinity, see here, figure see here. So here, anywhere, object position is anywhere, the image will form between focus. You see, the parallel rays coming, which is parallel rays of parallel to the principal axis and fall at this point and hit in this direction, and it will extend it, imagine it extend it will pass to the focus. Another incident will consider right. Another incident ray passing to center of curvature. This two will appears to meet here again as the image which is formed A dash B dash image formed by the image formed by the object AB. So always in case of image formation, in case of convex mirror, it's always diminished and actual image and direct. See the summary of the image formation of convex in infinity and was behind position of the mirror, position of the image at focus, behind the mirror, highly diminished and virtual and erect, between infinity and the pole, between the pole and the focus is diminished and virtual and erect. This is the this is about the reflection convex mirror. Then uses of what are the uses or applications of convex mirror? It is used as a rear view mirrors in vehicles, enabling safe driving of the vehicle. Each and every vehicle you see the mirror, see the to have a vision of backside view, to have a backside view and driving the vehicle. This type of mirror, convex mirror, see the moving object from at the back. So this is all about your reflection of convex and concave reflection to a concave and convex mirror applications. You know, when the image is formed or due to the position of the object at different positions, you have to find out different parameters. What are the parameters? Suppose this object distance, object distance. What is the object distance? Object distance is the distance between the pole and the position of the object. That is object distance. What is the image distance? Image distance is the distance between the pole and the position of the image. What is the size of the image? Size of the image is the height or size or height of the image. So people asked several problems and exercises on the reflection in spherical mirrors. You have to find out what is the there is a equation when solving this problem. It's called mirror equation. We will read in later stage. And before it, we have to learn about the sign convention. The which type of parameter or which type of parameter take which type of sign, whether positive sign or a negative sign. Then only you can solve the problems on reflection spherical mirrors. In our next class, we will discuss sign conventions and few problems on reflection and try to solve those exercises. This is for today only, and discuss the rest in our next class. Thank you.